Hi again, it's just a quick run through what we did for workshop 9. There we go, previous workshop on the two-way ANOVA, between groups ANOVA, looking at the effects of smoking on people's perception of different spiciness of curries and whether or not there was a main effect for whether you smoked or whether you had a mild curry or not, and a possible interaction between your smoking status and the hotness of the curry. The outputs that we provided included box plots, Levine's test, and so on. I'll just run through that. So here's an example of one of the outputs we looked at. Histograms for the smoking mild condition and the non-smoking mild condition, and you can see that there's some evidence that this one's maybe a bit skewed, but not so much for this one. Doesn't look so skewed. But when we look at the box plots, it looks like there's one group that stands out from all the others. So this is suggesting to us that our non-smokers, when they eat a hot curry, are very more apt to rate this as being extremely spicy compared to any type of curry for the smokers or the mild curry for the non-smokers. We also provided histograms, so the question didn't ask you to evaluate this. It's a little bit awkward, isn't it, to explain why you get this sort of steppiness kind of look to it. Okay, but actually this appearance corresponds to the gaps in the histogram. It comes about for the same reason, is that people are rating on a scale that's 1 to 10 or whatever it was, so they can only give you answers of 1, 2, 3 and so on, so you get gaps in the middle, as here. So this bin in the histogram says that there were 5 people who gave a rating between 2 and 3, namely they gave the answer 3. Okay, and that would correspond to the people that are in one of these groups here. 1, 2, 3, 4, 5 people there. It's probably that plot there. Okay, so that's to give us some overview. It looks from the box plots though that the distributions are fairly well centered and symmetric, so that's a good basis for assuming that they are normally distributed. And then if we look at Levine's test for homogeneity of variance, that's to see if the variance is similar across all of the groups, which is required for the ANOVA. We find that because there are 4 groups, there's 3 degrees of freedom. The F value is quite small, and as a consequence the probability of getting this F value would be quite common if indeed the variances are all the same. Happens 86 times out of 100. So in this case the assumption of homogeneity of variances across the group is the same, and that corresponds to the box plots all having the same kind of spread and sizes of box and so on. Okay. The ANOVA table then gives us reports for the individual factors. Okay, so smoking status, if you treat just that aspect of the study, okay, we find that has a very large F value, and so it suggests there's an effect of smoking status. And similarly, if we ignore how people smoke and just look at whether there's a difference between ratings of people's spiciness of the two kinds of curries, again we find that the likelihood of them being rated the same is very small. The p-value is 0 here. Okay. But then the third case is where we have an interaction. If the spiciness of your rating of the curry depends on whether you're a smoker or not, those two things together, you see, and indeed this is the case. There seems to be this combination of things going on, and that corresponds in our box plot to this chap being standing out from the other 4 group members. Okay. When there's an interaction effect present, okay, it means that the interpretation of the main effects is incomplete, so you can't look at these on their own, and it's often tricky to work out what's going on. In your textbooks you'll come across different descriptions of interactions. You can get so-called ordinal interactions when the slopes of the lines are different. See, these are quite different, a steep line and a nearly flat line, okay, but they don't actually cross, and this would be called an ordinal interaction. And alternatively, if this would have been going the opposite direction and crossing each other, this would have been called a disordinal interaction. In either case, it means that the combination of the factors is influencing things, and you can't simply add the two individual effects together. You need this extra term that we talked about in the lecture last week. After you've done your run over, you can look at the significance of individual group components together, so you can contrast the two different types using, for instance, Tukey's test. Tukey's HSD, you can proceed directly to this. If you're only interested in pairwise comparison, you're not obliged to use the ANOVA at all. Okay, but if you want to do something more complicated, you may want to do an ANOVA, or if you've got no a priori hypothesis about which groups to compare, then you would want to do the ANOVA anyways. But the Tukey's test gives you pairwise comparisons between all the possible groupings. Okay, and you can look at these to see what the principal effect is, and by looking at your box plot, you can pretty much tell what that is. It's the fact that the non-smokers find the hot curry really hot, whereas everyone else finds them, if they're smokers, they don't really mind whether it's hot or not, and in fact they respond about the same as the non-smokers do to a mild curry. Okay, so you can tease that particular information out of this table. The effect size is our eta squared measure is simply calculated as the total sum of squares for the condition of interest, A, compared to the total sum of squares across the whole table, and we just simply add up all of the different elements of the sums of squares. So we get a sum of squares for condition A, for condition B, for the interaction term, and the residual sum of squares all together. That's what this part says here. And then we just see what fraction of our particular effect of interest, in this case 72 the smoking status is, compared to everything. That works out to a particular fraction. You see, 16% of the variance is explained by smoking status, and that's our effect size. Okay, end of slideshow. Thank you very much.